So good morning everyone and welcome to this third webinar about Kyle MDK ARM. My name is Björn Skånberg. I work as support engineer here at Nohau, and today I will talk to you about how to build your own software pack in MDK 5. So 2 weeks ago, the first webinar, I talked to you how and what you need to start a project, what software packs are available, where you find them. I showed you how to add and remove components within the runtime environment, and I showed you what templates are available and where do they come from. Last week, I talked to you about debugging and trace with Uling Pro. I showed you what different views are available. I talked about the core site, what you need to get trace, and what you can expect if you have 1 pin of trace and if you have 4 pin of trace, what different views and results. So today I will talk to you about software packs, how to create them, how you can do versioning control with them. I will also show you how to create your own configuration wizard, and then we will end with a Q&A. So real quickly, just show you the SEMSys 4 version. So this is the Cortex-M standard interface from ARM. So your software pack can be anywhere in this diagram, or it can be a combination of different levels. So it's up to you to decide what your software pack should contain. So basically, a software pack is a delivery mechanism for software components. So it can be, for example, a SEMSys core, a network, some processor memory, or something like this. It could be board-related drivers, manuals, vendor information, or just some piece of code that you have produced and you would like to save within your company, and you would like your coworkers to have easy access to it, and you would like to use this in the future. So what you need is to create a pack description file, a PDS file, which is basically an XML file. And the XML file you have created is telling where the source code and header files are, where the documentation is, if there is any templates, and if there is any examples and such things. And then you need 7-zip, the program 7-zip, to pack this into a software pack. But I will be showing you this later on. So generally, there are 5 use cases of software packs. And the one I will talk to you about today is the in-house software pack. So usually you have the device family pack from your silicon vendor, where there is drivers for your MCU and such things. You have the SEMSys pack from ARM, which is the standard interface for Cortex-M. You have the middleware pack, which usually comes from third parties. For example, the GUI pack from Seger if you buy the MDK Pro. And then you have the board support pack, which gives you device drivers for the different LEDs, potentiometers, and what you have on your board. So what I hope to learn to you today is that you should start using the in-house software pack to use code again and again, so you don't have to rewrite things that you have already done, and to do this in a simple and easy way. So how to create a software pack? Well, there are tutorials, and there are tutorials on the web. So you can either go in your hard drive here and open it, or you can go on the web. So I will just show you where you can go. You can go to this address. It will give you some description how to create a pack, like you have to produce the source input, and then you organize your files so you know where they are. You generate the pack description file, and then you will verify it against a pack XSD file, and then you will generate the pack. And then there is an application called packcheck.exe that will check the pack for consistency. So here you can also download some examples as well. Yes, and then you have, for example, how to create a pack with software components. So you can just follow these examples and you can easily start doing your first software packs yourself. So just before we go into the technical stuff, so this is the contact info. So if you have any questions, technical questions, please contact me, Björn Skånberg. Or if you have any sales questions, please contact one of my coworkers. So let's start. So I have created on my board, I have created a piece of source code that will make the LEDs blink in a very cool way. So let's say I want to share this source code with my coworkers, and I want to add easy versioning control of this piece of source code. So then I need to create a software pack. So I will go into the folder where I have the source code. So the source codes are in files. I have some documents where I have a license agreement. See, it comes in my other screen. Here I have a license agreement. I have a README. I have a template, so how to call this cool LED function. And then I have the source code in my software component. So the cool LED C is the one that does the blinking, and then cool LED C is using my libc for different functions. So I would like to pack this in a software pack. So how do I do it? Well, first of all, I will show you the script that actually does the packing. So this is a script that is pre-made by Kyle. I haven't added anything to this script, but there are two things you need to know about this script. First, it will look for files in a directory called files. So if you have your script in your root catalog, then you need a sub catalog that's named files. And here it will start looking for software, source code header, and such things. And then you need to edit where is your 7-zip executable. So if it's not in this location, you have to change this. This is all you need to know about this script. And to produce a pack description file, I will show you how this is looking. So this is an XML file. So I will turn on the XML so it becomes a little bit clearer. So there's basically one thing that's very important with a pack description file. It's the vendor name, which here is Nohau, and the name is cool LEDs. So your pack description file needs to be called, in my case, knowhow.coolleds. This is important. Otherwise, there is really no naming convention beside this. So let's start creating our first software pack. So vendor is Nohau, the name is cool LED. What does it do? It make the LEDs blink cool. If you have any support, who can you contact? Well, you can contact me. If you have any questions, if my coworkers have any questions. And I have a license agreement, which I showed you before, that's located here. So now I need to add some components. So I have prepared this before, so I will just paste this in. So I have prepared a component. It has documentation with README, 2 header files, and it's mylib.h and coollib.h. Then I have source files here, and they are located in this folder, my software component. And then I have a source file for a template for a main file, which I will put this attribute as template. And then next to it, I will have the info text saying main module for CoolLED. So this is what I need to create this software pack. I will save. I will open my CMD. I will go to the folder where I am, like this. All I need to do now is call the script generate pack, and then it will generate a pack for me. I click enter, and you will see everything is okay, and a software pack has arisen. So now I need to install this software pack. So I will go into Microvision. I have my pack installer open. So I need to import this pack. So I will go File, Import. I will go to the folder where the pack should be, Nohau CoolLED 1.0.0. I will open. So first, my license agreement comes up. So this is a license, please accept it, otherwise the pack will not be installed. So I will agree to this. And I click next. You see it's processing down here. And now I have a pack, a Nohau CoolLED 1.0.0. And the description says it will make the LEDs blink cool. So let's add it to a project. So I will go project, new Microvision project. I will go to my folder where I want to put it. You can create a new called project, and we can call it CoolLED. Save. So I'm using the STM32F407 IGHX. So I will add this. So as you can see now, there is a component called Nohau, which I can select. So this is quite neat. So how did it appear up here? Well, first off, I will show you a slide of how this is working. So we have here something called the C class, and the C class in the example is drivers, C group is Ethernet, and then C sub is KSZ this. And you can put C version, C variant, and description. So this I have done in my pack description file. So C class was Nohau, C group is CoolLED, and C sub is webinar CoolLED, and the C version is 1.0.0. So because I put this, it will be shown like this. So this is a quite good way to denote that this source code doesn't come from outside, it's within your own company. So I will add this. I will click OK. And now you see that my 2 files has been added. As I told you, I also put a template which I can add. So I will go Options, Add New Item to Group, User Code Template. I will click Nohau and then CoolLED, Webinar CoolLED, main.c, and this main module for CoolLED. So I will click Add. Okay. So now I will try to compile. As you can see, I get some errors because my software pack is dependent on the hardware abstraction layer from the STM32F4 family and also the Kyle RTX. So it would make sense if when I'm adding my component, I need some kind of condition saying that to be able to use the cool LED, you need to have this and this. Like if you going to use the Kyle RTX, Microvisioning is telling you, yeah, you need Kyle device startup. So let's add such a condition. So I will go into the pack description file again. I will add a condition here, which I have pre-made. So the condition ID is called LED, and it needs the driver common and the driver GPIO from STM32Cube HAL, and it also needs Kyle RTX. So I need to add this to the component. So I go condition equals LED. Like this. I will change the version to 101, and I will change the version up here to 101. I will save, and then I will generate a new pack. So I will just run my script again. It was okay, and you will see that a pack for 101 has now been created. So let's add it to the pack installer. So I will go File, Import, Nohau Cooled 101, Open, License Agreement. Like this. Okay. So now, yes, I would like to reload the software packs. And, now I forgot something. Let's continue. I will add it in the third version. So when I click now in the runtime environment and I try to choose Nohau, it will say, okay, to be able to choose this, you need these various files. So I will click Resolve, and the files will automatically be added. So now I should be able to compile. Like this. You see it has been compiled. And if I download to target, downloaded. So if I hit the reset, you see that the LEDs will be blinking again in a very cool way. So let's say that you want your coworkers to be able to add or do some modification to your source code, because right now I cannot change anything because there is this key on the file. So all you need to do is go into the pack description file, and you just have to put an attribute saying I would like this to be config. So if you do this, then your coworkers can edit your code. So I will make a new pack. So save, generate a pack. Pack 102 is here. Install the pack. Yes. So now you see I have 3 different versions of this pack, and I would like to reload the packs. So now you see that the cooled can now be, I can now edit the cooled, which is very nice. So I told you also you can do some versioning control for this. So let's say you are developing a new project, and then you probably want to stick with the latest version of everything. Then the next day you need to do some maintenance of an old project, and you want to recreate the environment that this project was created with. So then you have the select software pack, which is basically telling you what versions you have selected. So now I'm using the latest versions. So if I deselect this one, I can go ahead and use an older version of the Nohau Cool LED, like 101. So I click OK. You see now this is locked again, and you can see it also in the version here, it's 101. And then if you want to change back, you will just have to do use the latest version of the installed software pack, like this. And you will see in the runtime environment that it's 102. So this is how you can maintain control of what version you are using. Next, I will just show you quickly how to use the configuration wizard. So the configuration wizard is if you need to set some values. So I have prepared it before. So what you need is you have to have this as the starting line, and you have to have this as ending. And then you need to close the file, open it again, and you will see the configuration wizard will appear. So there are 3 ways of editing a value, which I will show you. So if you have, for instance, you want to enable the certain LEDs, you have this that will edit the LEDs bit by bit. So we have here bit 0, and you will enable or disable this, bit 1 up to bit 7, and this will affect this value down here. So, and then we have this, the header, which is basically just the headline for what it will say in the configuration wizard. So this is pretty good if you have your coworker want to add some features that you have done with the certain values. So here you can just click these values, these boxes, sorry, and then you will see the value here will be changed. So if I click a few more, this value will be changed. The next off is if you want to put like some kind of threshold or something. So we have the header again, set what LED should be on the second time. And then we have that it will affect bit 0 to bit 7. And the value should be between 0 and FF. The I's here are just for information. So if I save and go to the second, set what LED should be on, and you can put here any value you will like within the range. If you try to put a value that's not allowed, Kyle will tell you that it's not possible and put something that's available. So last but not least is the how to make a drop-down menu. So the header again and end of the header, and then you just say what LEDs should be on, and then for all you will have FF for even, odd, or none. You can choose one of this, and then the third will just make a drop-down menu. So this is if you have some kind of configuration and you want to give what pin should the I2C or something be configured to. So this is a quite nice way of giving the user a little bit easier to configure this value like this. So in my example, this doesn't really necessary to make a configuration wizard because it's only 90 lines long. But if you have like the RTE device.h, which is 2000 lines, it could be quite nice to have the configuration wizard to say that, okay, I have the I2C. Yes, I want to enable it. What pins should I use? Yes, I want PB8 and I want PB9. So for this use, I think it makes more sense. But I just want to show you real quickly how you can manage this yourself. So this was the technical stuff for today. So I showed you how to make your own software pack. how you can keep control of the versions, and a little bit how to make your own configuration wizards. So for technical questions, contact me, and for sales questions, contact one of my coworkers. So I will stop the recording now.